Hello, Indie Paladin here. In this video I wanted to run some benchmarks to showcase the capabilities of OP Tween. OP Tween is my tweening engine built with simplicity, performance and memory footprint in mind. At first I recorded this video with tween only, but I found out after that prime tween is actually much faster and less memory intensive as long as you disable assertions. And I decided to include it in this benchmark test. Let's run benchmarks.exe. I will be testing these three tweening engines' performance measured in average FPS per benchmark, making sure I use all of their available easing functions in a balanced manner. Tweening 32,768 transforms, positions, scales, and rotations. Each button on the left and the right corresponds to a benchmark for these three engines, with each benchmark taking 3 seconds. The average FPS will be shown on the top center of the screen. I will run 3 benchmarks, one after the other for each engine, and then also run a combined test for each. So let's see how these 3 stack up to each other, starting first with OP Tween. So position, scale, and rotation. Good. Now we reset. Go with prime tween, position, scale, rotation, reset. Now do tween, position, scale, and rotation. Great. Now let's run the combined tests. OP tween, position, scale, rotation. Good. Reset. Prime tween, position, scale, rotation. Nice. Reset. Now do tween, position, scale, rotation. As you can see, OP Tween is clearly the best, followed by prime tween and then do tween. This was an IL2CPP build for maximum performance, but I also have a mono build which I wanted to show as well. So let's run this test in the mono build. Benchmarks.exe. Let's follow the same pattern, starting with OP Tween, position, scale, rotation. Now reset, go with prime tween, position, scale, rotation. We reset, go with do tween, position, scale, rotation. Great. Now we reset and go for the combined test, OP tween, position, scale, rotation. Good. Reset. Now prime tween, position, scale, rotation. Great. Reset and now do tween, position, scale, rotation. Great. Again, we have similar results with OP Tween being the best, this time with quite the margin, showing the least performance drop compared to the IL2CPP build. One final test I would like to do is see the memory footprint of each engine. We can see that inside of Unity's profiler. So let's jump into Unity. Here we are. Let's just show the player settings for a second here. We're using IL2CPP here, and we have the define for prime tween to disable the assertions. Great. We have our profiler here, it's deep profile, and we are going to run the position tween for each engine. And let's see their garbage collection allocation. Let's start with OP Tween. Great. Let's pause, navigate to this spike. Great. And let's find the actual method. It's this move transform 1.8 megabytes. Good. Now let's run prime tween. Pause, navigate to the spike, and let's find the actual method. Tween.position 12.9 megabytes. Great. Now let's run do tween. Go to this spike here. Find the actual method, do tween.2, 13.7. So as you can clearly see, OP Tween is like 7 to 8 times better in terms of the memory allocations. But let's run one more time each. Start with OP Tween, prime tween, and then do tween. And pause. Great. Again, let's find the methods. So move transform, 0 bytes. Let's see. Just find the correct frame. Not this one. This one. Yes. Tween.position, 0 bytes as well. And then do tween.2, it's 11.8, so similar to the first time. So both OP Tween and prime tween do not have any extra garbage collection allocation after the first time they run. Good. I hope you found this test useful. You can find my engine in the Unity asset store called OP Tween. The link is in the description, and have a good one.